Welcome to the deep dive. Today we're not just talking about the sheer fun of flying through the air on a zip line.
No, it's more than that.
Yeah, we're really digging into what keeps us safe up there, specifically looking closely at braking systems, how essential they are.
Absolutely. And our look today, it draws on quite a mix of stuff, doesn't it? We've got internal emails, the actual code of ethics for engineers.
Right, and a really detailed analysis focused on emergency braking.
It's kind of amazing, how something that feels so free, like ziplining, actually depends so much on these complex safety measures working perfectly.
That feeling of flight, it's incredible.
It is, but it's completely reliant on having solid, dependable safety stuff in place. That's really the core of what we need to unpack today.
Exactly. So our mission, if you like, for this deep dive is to try and wrap our heads around the current challenges with zipline braking. What are the sticking points and what solutions might be out there based on the info we've got? One thing that jumped out right away from the sources is this idea that just, trusting your gut isn't enough. Not when you're dealing with safety at these kinds of speeds and heights. An early email we saw really flagged that concern, maybe too much reliance on just intuition.
That's such a critical starting point. Look, intuition, experience, they have a role, sure. But when you're talking physics, like potential energy turning into kinetic energy, speed, you have to be grounded in hard data, rigorous engineering.
Okay, let's get into it then. The current state of play with zipline safety, some of the numbers we saw are, frankly, a bit concerning.
They are.
Granted Insurance, they reported something like 6 to 7 accidents per 100,000 riders back in 2020.
Right.
But then their projection for 2023, it leaped up to 15 per 100,000. That feels like a pretty big jump in just a few years.
It is a significant increase. And, when you drill down into why these accidents are happening, it gets even more, troubling.
How so?
A review looking at incidents from 2016, this was after the legal time limits had passed, it showed that over half, more than 50%, were linked to braking problems.
Over half.
Yeah, think about that. More than half the accidents coming down to issues with stopping the rider safely.
Wow. Okay. But it's not all bad news, is it? The sources did mention some positive steps, like friction and spring braking systems being included in the 2019 ASTM standard update, F295919.
Right. ASTM, the American Society for Testing and Materials. That was a good step. And there's a really strong example of success, too, the Park City Mountain Resort Zipline. It's been running since 2002.
And their safety record specifically for braking is excellent.
Apparently so. Attributed to a fail-safe trolley design and a compression spring setup that works really well.
So that Park City example, it shows it can be done right.
Exactly. It shows that when you apply solid engineering to the braking, you get effective results. You prevent accidents. Their track record really speaks volumes.
Okay, but here's where maybe things get a bit more complicated, raise some questions. Auto-resetting emergency brakes. They've technically been required for zip lines hitting speeds over 6 mph since about 2012, right? Under the ACCT 8th edition.
ACCT, yeah. Association for Challenge Course Technology. That's the standard.
But the accident reviews, they suggest these systems aren't maybe as common in practice as that standard would imply. There seems to be a bit of a disconnect.
That gap is a major red flag, a big one. The whole point of an emergency brake is to be the backup, the safety net if the main brake fails or isn't enough.
Right.
So if those auto resetting systems aren't actually there or aren't working reliably, that vital second layer of safety isn't there.
And that leads straight into another big worry highlighted in our sources, the idea of increasing zipline speed limits. The concern is if speeds are going up, but you don't have widespread mandatory auto-resetting emergency brakes, well, you could be dialing up the risk.
Definitely.
They talk about participant entropy, which sounds technical, but I guess it just means people are people. We get tired, distracted, make mistakes.
Exactly. Human factors.
So you combine that sort of natural human variability with a system where someone has to manually reset the brake after every single ride.
Yeah, that sounds like asking for trouble, especially because rider weights are all over the place. Weather changes. Speeds aren't constant.
Absolutely. Repetitive tasks like resetting a brake are just prone to human error. Attention wanders, people get tired, maybe rushed.
And like that first email pointed out, if conditions are changing, heavier rider, sudden tailwind the operator has to be constantly vigilant, constantly adjusting, relying on manual resets in that kind of dynamic situation. It adds a huge amount of, unpredictability, risk.
And putting a really sharp, tragic point on this, the sources mention 8 zipline deaths reviewed just in the past year.
Yeah, that number really hits home. It underlines the human cost when braking systems fail or aren't adequate.
These aren't just statistics.
No, absolutely not. They represent real people, real tragedies. It just highlights how urgent it is to get this right proactively.
Okay, let's shift gears a bit and look at this from the engineering angle.
Yeah.
We had excerpts from the NSPE Code of Ethics, National Society of Professional Engineers. And their number one principle, the first fundamental canon, it's crystal clear. Engineers have to hold paramount the safety, health, and welfare of the public.
That's the absolute foundation of engineering ethics. It's not just about making things work, it's about making them safe for people. That obligation ties directly into everything we're discussing about zipline brakes needing to be robust.
The code also says engineers should only sign off on designs that meet applicable standards, and they have a duty to report if they know about alleged violations. Plus, it stresses being objective and truthful in public statements, which seems pretty relevant given the analysis we're looking at.
It really is. Any engineer involved in designing or approving these zipline systems has a clear ethical duty to push for the highest safety standards. If they see risks or noncompliance, they're professionally obligated to raise the alarm.
And being truthful in public statements, that's key for transparency, right? Building confidence.
Absolutely. Public trust relies on that honesty.
Okay, so let's dive a bit deeper now into the specific problems identified with the current standards. ACCT, ANSI, American National Standards Institute.
Right.
A key criticism seems to be that requirement for emergency brakes only kicking in above 6 mil per hour. The argument is that this doesn't really capture the full picture.
Exactly. That single speed number is too static. It doesn't account for all the things that can change arrival speed, like temperature, for example.
How does temperature affect it?
Well, cold weather can make the cable contract, tighten up. That potentially increases speed. Warm weather, maybe the opposite, a bit more slack. Then there's wind.
Headwind slowing you down, tailwind speeding you up.
Dramatically, sometimes. And there was research, Vladich and others back in 2020, specifically pointing out how critical these environmental factors are. Standards need to reflect that reality.
And it's not just the environment, it's the person on the line, their weight.
Huge factor. The sources make this point really clearly. Someone heavier, say 250 pounds, carries way more kinetic energy than someone lighter, like 80 pounds, even if they arrive at the same speed.
Kinetic energy, like the punch they deliver when they hit the brake?
Sort of, yeah. It's the energy of motion. More mass means more energy that the brake needs to absorb safely. So a brake designed just for that 6 mile per hour threshold,
Right.
without considering the maximum weight under potentially worst-case wind conditions, it might just not be up to the job.
It might be overwhelmed.
It could be, yeah. The difference in energy between a light rider on a calm day and a heavy rider with a tailwind is massive. The braking system has to be designed for that tougher scenario, not just the easy one.
Which brings us back to relying on humans for critical steps, like manually resetting those emergency brakes.
Yeah.
We touched on human error before, fatigue, maybe inconsistent training, just a moment's distraction.
Yeah.
It can all compromise the reliability of that manual reset. There was research mentioned, Billick and colleagues in 2015, linking human error directly to zipline injuries.
It's a known factor. We can't eliminate human error completely, of course, but we can design systems to minimize its impact. Relying on manual resets puts a huge amount of faith in consistent, perfect human performance, which, well, that's just not realistic day in, day out.
The idea of entropy came up too. How does that fit in?
Entropy, yeah. It's basically the natural tendency for systems to become more disordered over time. So with manual resets, maybe the brake doesn't get set quite right one time. Maybe the procedure isn't followed perfectly every single time. Maybe there's wear and tear that isn't noticed immediately.
It introduces unpredictability.
Yeah, exactly. Unpredictability and a drift towards potential failure. It's just inherent in systems that rely heavily on manual intervention for critical safety functions compared to a well-designed automated system.
Okay, so given all these issues, the limits of current standards, the environmental variables, the human factor, entropy, what's the proposed way forward?
The sources really point strongly towards automated braking systems.
Automation.
Yeah. The core idea is simple. Take the human variability out of the emergency braking loop. That way, you get consistent, reliable performance every time, no matter the wind, the rider's weight, or if the operator's having an off day.
That makes sense. Consistency is key for safety.
It's crucial. Automated systems can be engineered for precise, effective response time after time. They don't get tired or distracted.
And the comparison made in the sources is really powerful, isn't it, to roller coasters?
It really is stark. You look at the accident rates, zip lines, we said maybe 15 per 100,000 projected.
Yeah.
roller coasters, dealing with much higher speeds, huge forces. Their rate is something like 1 in 16 million.
Wow. That's orders of magnitude different.
It is. And the argument is that a huge part of that difference comes down to the roller coaster industry's deep reliance on automation, on redundancy, having multiple backup systems, plus really strict inspection routines, and just precision engineering in their braking.
So they've embraced automation for safety.
Heavily. It shows what's achievable when safety is driven by robust automated engineering. It's a clear benchmark.
And this ties back to the engineering ethics we talked about earlier, right?
Absolutely. Moving to automation isn't just about better tech. It's fulfilling that ethical duty to protect the public. You're actively designing out the known risks associated with human unpredictability in a critical safety system.
It embodies those principles of redundancy, fail-safe design.
Exactly. If one component has an issue, another system takes over safely. That's modern safety engineering.
So if the industry were to really transform its approach to braking safety, what are the concrete steps needed? The sources laid out a few key recommendations.
Yeah, the first big one is revising those ASTM standards, F2959. They need to go beyond just speed thresholds.
Wow.
By properly incorporating dynamic factors, temperature, wind, and crucially, participant mass variations. And they should require daily checks of actual arrival speeds, not just relying on design assumptions.
And mandating auto-resetting emergency brakes.
Yes, mandating them for all zip lines, not just those over some arbitrary low speed like 6 mile per hour. That threshold seems inadequate given the variables.
Okay, what else?
Second, a clear mandate to transition the whole industry towards automated emergency braking systems. Really learn from the success of the roller coaster model.
Make it the standard, not the exception.
Precisely. Third, develop much tougher, more comprehensive testing protocols for all the safety gear. These tests need to simulate real-world stresses, high winds, maximum weights, repeated use to make sure components hold up.
Not just lab conditions.
Right. Real-world readiness.
Yeah.
And finally, adopting a full systems engineering approach.
Meaning
Looking at the zipline as a whole integrated system, the cable, the trolley, the rider, the environment, the brakes, and designing safety solutions that consider how all those parts interact, rather than just tweaking individual bits in isolation.
That makes sense. It's all connected. There was also a brief mention of how participants might perceive these changes.
Yeah, that's an interesting angle. The idea is that visible safety measures, like seeing robust automated brakes in action, could actually boost people's confidence.
Makes them feel safer, more likely to try it.
Potentially, yes. It enhances trust. If people see the industry investing seriously in state-of-the-art safety, it can only improve the industry's reputation and maybe encourage more people to participate feeling secure. Transparency and visible safety matter.
Okay, so as we start to wrap this up, let's summarize the main takeaways from this deep dive into zipline braking.
Well, I think the analysis makes a pretty strong case that current standards and the common reliance on manual emergency brake resets, they pose some significant safety risks. Because of those environmental variables that aren't fully accounted for, the big differences in participant weights, and just the inherent potential for human error in manual systems.
Right. And the core argument emerging from all this
is that automated emergency braking systems offer a really practical, effective, and ethically sound solution. The comparison with roller coaster safety systems shows a clear path forward.
Learn from what works exceptionally well elsewhere.
Exactly. It's about embracing engineering solutions that deliver consistency, reliability, and actively remove known risks tied to human intervention in these critical safety moments.
So here's something to think about as we finish. Consider the wider picture of safety standards in adventure activities generally. How often do we maybe rely on what just feels right or what's always been done instead of really pushing for data-driven engineered solutions?
That's a great question. Could other activities benefit from this kind of shift towards more automation, more rigorous engineering?
Could be ziplining today, but maybe other things tomorrow. It makes you wonder what other safety measures that seem intuitive might actually be improved with a deeper, more analytical, maybe more automated approach. Something to ponder.
Definitely food for thought.
Thanks for joining us for this deep dive.